A ship leaves port at noon and heads due west. Let's go ahead and draw. Let's say this is port. Port. And heads due west at 20 knots, which is nautical miles per hour. At 2 p.m., the ship changes course. Let's go ahead and draw then what we know about this length. So from noon to 2 p.m., that's 2 hours, traveling at 20 miles per hour. So this is going to be then 40 miles that the ship travels before changing course. Okay, the ship changes course to north 54 degrees west. So let's go ahead and draw that. This is a bearing. Here's the north-south line. Okay, and from north 54 west, okay, that's going to be something like this. So this angle right here, that's our 54-degree angle. Find the ship's bearing and distance from port at 3 p.m. So that's 1 hour later, which means then that the ship has traveled, since it's traveling 20 miles per hour, that's going to be 20 nautical miles. We want to find the ship's bearing and distance from port. So that's this thing right here. We want the distance and then the bearing, how we would measure that. So let's go ahead and do our, well, fill in what we know. First of all, this angle right here is 54 degrees. And we know that this angle is 90 degrees. So this angle as a whole is 90 plus 54, which is 144 degrees. So here we have a side angle side situation. So we know we can use the law of cosines to find this other side. Let's go ahead and do that first. We'll call this angle A. So the side over here is length A. And then we'll call this B and C. So that's side B and side C. All right, so law of cosines, A squared equals B squared plus C squared minus 2BC cosine of the angle A. A, we do not know. B, we've got 20 squared plus C is 40 squared minus 2 times 20 times 40 times the cosine of the angle A, which is 144 degrees. So A will be the square root of all of this. Let's go ahead and do that. Square root of 20 squared plus 40 squared minus 2 times 20 times 40 times the cosine of 144 degrees. I am in degree mode, so it knows that that is degrees. All right, so this here is side length A. I'm going to go ahead and just keep that there in the calculator because I'm going to be using it here, but I'll write out our rounded. It's about 57.4. 57.4. Okay, and that's, of course, in nautical miles. Okay, I've got that. That's the distance. The ship's distance from port is the 57.4 miles, nautical miles. But we also want the bearing, ship's bearing. And the ship's bearing from port, we can see that it's mostly north. So we're going to be measuring from the north line. Okay, and we're looking for this angle. It's going to be north, some angle, this angle, and then that's, of course, to the west. So we're looking for that angle there. Now, to find that angle there, we can see here that this here is a right angle. So if we can find this angle of the triangle, then we've got it. Okay. Well, that angle, that's angle B. Okay, to find angle B, we can use either the law of sines or the law of cosines. I'm going to use the law of sines here because I've got side length A and angle A and side length B, and I'm looking for angle B. So my law of sines, sine of the angle A over side length A equals sine of the angle B over side length B. Since I'm looking for angle B, I'm going to multiply by this side length B. So B times sine of A over A equals sine of B. And then, of course, we'll be doing the sine inverse. So sine inverse of, let's go ahead and plug our numbers in. B is 20. Sine of the angle A, 144, over side length A, which was what we found here, about 57.4. And that will be our angle B. So we're going to go plug this into our calculator. And when I do this 57.4, I'm going to remember that I actually want this exact number here. So we need our inverse sine. So trig down to our arc sine of this fraction, 20 times sine of 144 degrees over, now that 57.4 is actually the last answer that I got. So I'm going to do second and then this button down here to get that answer, the last answer that I have. And then hit enter, and that is going to be our angle B, about 11.8. 11.8 degrees. All right, well, now that we have angle B, we're actually looking for this angle here. We found this small one right here. And to get that, we'll subtract this from 90. Okay, so our bearing angle will be 90 degrees minus 11.8 degrees, which is 78. Crazy me, 78.2 degrees. And so that's what we fill in over here, 78.2 degrees. So the ship's bearing from port is at a bearing of north, 78.2 degrees west.